Hi all. Just wanted to share a sort of brief inventor tip that I found very helpful for certain types of assembly modeling, and that's the use of a phantom design part to represent the overall assembly, and then utilizing blank geometry parts, which I'll explain shortly, to fill out the bill of materials. So this type of assembly modeling I've used fairly extensively in factory design automation because most of the time when working with factory assets, you actually can't use level of detail because your assets may be read-only. So what this method espouses is to create a representative part, the phantom part in this example, that shows the different characteristics of this particular subassembly. And that's the only part I manipulate. But by setting its BOM status to being phantom, it doesn't show up on the bill of materials. So let me give you an example. This is just a structural support channel with some plates that could be welded. And you'll see here in my model browser I've got four components. I've got a main, I've got a support type 1, and a support type 2. But you'll also see I have this phantom part. And the phantom part, as I click on it, is actually the only one that highlights. And the reason being is if I look at the bill of materials, in the model data, it's the only one that has any geometry in it. So what we're going to be doing a couple things in this tip. We're going to be showing this bill of materials which has no geometry for some of these parts. So they're only there for quantity and to fill out a parts order or something like that. But the phantom is actually the one that we're going to place into the the design, and that's the one that changes. So it's done a couple different ways. So the first thing is I create a phantom part. So this is just it could even be a multi-solid body part if you want. I didn't choose to do that. I just have several features. I've got my main extrusion, I've got a set of supports that are currently turned off, a second set of supports, and then if we want the opposing piece on the other side, we have a mirrored feature. So it's just straight up inventor part modeling. Nothing really too crazy there. But what's unique about it is when I go to look at the tools, the document settings, I set the bill of material status to be phantom. That means the geometry comes in and I can use it, but it doesn't actually show up on the bill of materials. And so that's why when we come back here, I have my geometric representation, the phantom part, but then I have a bunch of empty parts that I use to populate the BOM. This is all controlled via iLogic. So if we look in here at the iLogic, and I'm not going to go through every single aspect of this, but if we look at the iLogic structure, what I'm doing is I'm turning off and on the local occurrences of the bill of materials, meaning I'm setting just this instance of support 1 and support 2 as being reference. So the reason why this helps is that I don't have to change it all throughout every single assembly where these are used, just in this particular assembly. So that's the first part. And then I'm just simply passing parameters from the assembly into that phantom part so that my graphical representation of the subassembly can adapt. And then the rest of this logic is just bill of materials manipulation. When do I turn on support 1 or support 2? And then if I want one on the other side, it'll add a quantity of 2 to the bill of materials. So this is the other important aspect when doing this type of modeling, is I only need to place one type of each blank part, and then I'll actually use rules-based design, iLogic, to control the quantities. So instead of having to place, say, 30 fasteners, I could just place one fastener and then using different rules come up with the final bill of materials count. So I'll go ahead and close that, and then just to show you how it works, I will come up to the assembly. Let me resize this just a little bit so you can see what this looks like. So if I toggle between the support types, now we've got support type 1. If I only want it on one side, I turn that off, and then we can change the length maybe back to 72 and reposition that support somewhere along the model, let's say 50. So in just a matter of a few entries, I've now repositioned and reconfigured my phantom part, And then if we look at the bill of materials, we can see, if we look at the structured tab, that I went down from support 2 to support 1, and that quantity is only 1 because I'm only using it on one side. So this is a great technique for taking a more complicated assembly that might have a lot of parts in it, but really their parts are very standard. So for example, I might have stock part drawings for each one of these plates, and so I don't need to recreate a new part drawing every design. I just maybe have to reposition them. So this is a great technique for that because I'm not producing part drawings, and I can reduce a very complex assembly down to a more simplified part driven with iLogic rules that also can control the explicit bill of materials. So I hope you find this tip helpful. If you have any questions or comments, please feel free to reach out to me. Otherwise, hope all is well and have a blessed day.